Yeah, well, thank you everyone so much for joining us today. My name is Sam Stevens, and I'm the RF account manager here at Berkeley Nucleonics. I'm joined by my colleague Edgar.
Hi, I'm Edgar Guzman. I'm one of the application engineers here at Berkeley Nucleonics, and it's a pleasure to be showing off one of our exciting instruments as well as some of the instrumentation from Valon Technologies.
Yeah, absolutely. So yeah, like Edgar said, we're going to be highlighting Valon Technology and our long-time customer, Stuart Rumley. So Stuart is the founder, owner, and CEO of Valon Technology. And Valon designs and manufactures RF signal sources and other related products for a wide array of RF applications. And yeah, without any further ado, let's dive into the presentation. Okay, so just a bit of a run through, just going through Berkeley Nucleonics. So for those familiar with our company, we're called Berkeley Nucleonics Corporation, or BNC for short. We were a spinoff of the Lawrence Berkeley Labs in the San Francisco Bay Area in 1963. When we started out in the RF industry, we partnered with Anapico of Switzerland, whose RF developments include cost-effective, best-in-class performance. And as you'll see with the 7000 series, it's a very dynamic, field-ready unit with really an impressive range of capabilities for the cost and form factor. And over its brief tenure, the 7000 series has become a go-to, reliable phase noise system for users in defense, communications, and general R&D fields. If you have any questions in regards to our RF line and how it can fit your application or budget, feel free to contact us, and we'll be sharing all contact information at the end of this presentation. And yeah, we really just pride ourselves on being able to provide our customers with cost-effective, reliable solutions, and then with that unparalleled sales and technical support. Okay, so here's our BNC service regions. So we have the United States and just North America fairly well, covered with representation. So feel free to contact us for your exact, regional representation. Our reps are available for on-site technical support and can present and coordinate demonstration units for your evaluation as well. And we really now have an even more streamlined way of qualifying the 7000 series for you with our quick PNT questionnaire. We can determine based on your survey submission if the 7000 series will work well for your application. Furthermore, once your application is confirmed, we can send a demo for your final evaluation and analysis. So within a matter of weeks from start to finish, you'll be able to determine if the 7000 series will meet your needs and application parameters. Okay, so about Valon Technology here. So Valon is a leading RF component manufacturer out of Redwood City, California, and its products include short-range radio transceivers, RFID readers, short-range transmitters, and a wide array of other RF solutions, and they're certainly cost-effective and reliable as well. So Stuart founded the company in 1987 and brings 30 plus years of experience in the RF industry to the research, development, and manufacturing of his products. His product lines are used for a wide array of RF applications at a variety of innovative companies, from molecular sciences to quantum computing. And yeah, if you're looking for ready, top of the line, ready to integrate sub-assembly synthesizers, we cannot recommend Valon enough. As we'll discuss, Valon started on the format of a consultancy, and it's really with this spirit that Valon continues to grow and meet its customers' needs. And we'll be sharing this at the end, but if you're interested to see if Valon's products are right for you, please visit ValonRF.com or contact sales@ValonTechnology.com. Okay, so here's a timeline of the inception of Valon Technology, along with an overview of Stuart's experience in the RF industry. So Stuart started out at Lockheed Martin High School as a tech trainee for the summer. He then went on to take a job in Lockheed's calibrations lab. Then that fall, Stuart was hired as a tech in the primary standards lab and worked there for 5 years. And this role, taught him a lot about the electronics and key principles, such as fundamentals of how to or how RF measurements are made. And then from there, Stuart moved on to Applied Technologies and worked in their advanced development department on radar warning receivers, and got more background on signal sources and signal processing. And then it was about this time Stuart began noticing the demand for RF consulting in the Bay Area, in particular the need to develop, modify, or repair RF products. So Stuart consulted in this manner for 30 years. And when he wasn't working, Stuart experimented on how to design synthesizers. And it was around this time when the internet and eBay were starting up, and he could have a platform for his RF sales. So the company was founded around 1987, primarily as a consulting firm. Eventually, Valon started manufacturing frequency synthesizers, and then Valon's first customers were Berkeley Space Science Labs and other radio astronomy firms and organizations. And since then, Valon's business has grown to include defense, quantum computing, and molecular sciences. Okay, so here's a little rundown of Valon's RF synthesizers. So they are manufactured in Northern California, and they really are perfect for applications that require especially pure and highly stable signal sources or timing clocks. And just to kind of list a few, so Valon's most popular products include the 5009, which is the 6 gigahertz frequency synthesizer, 5015, the 15 gigahertz frequency synthesizer, 5019, 20 gigahertz, 2 gigahertz hardware programmable divider, and the 4002 phase gain detector. All right, so just to compare and contrast a bit, just between our two product lines, we do actually both manufacture synthesizers, but we hope by the end of this presentation, you'll definitely have a better idea as to some of the main differences. So Valon synthesizers are components and are part of a larger system, and they are typically featured in onboard system integrations. So in other words, they get embedded or bolted into chassis along with other microwave components. So they're not, standalone benchtop instruments. And they can be powered directly by a DC power supply, USB, Ethernet, or a TTL connection. And then to contrast a bit, BNC units are freestanding and are systems themselves, and they're used for the testing of DUTs and other RF systems. And then in regards to our form factors, our synthesizers come in a 1U 19-inch rack-mountable chassis or a compact flange-mounted configuration, like the one on the left there on the slide. And yeah, both Valon and BNC synthesizers are used in RF R&D, such as with antennas, radars, and satellites, along with quantum computing and other very high-performance applications. And the difference, obviously, comes with the signal sources, where they're going to be needed in the system. And please reach out if you have any questions on a BNC or a Valon synthesizer would be better for your application. All right, now I'd like to hand off some of the phase noise testing components of the webinar to Edgar.
All right, thank you. So the PNT, or the Model 7000, is a phase noise tester. And to understand phase noise, you can see on the slide the two different signals, and realistically they're the same signal, but one is the ideal signal, what you expect to get mathematically. You're not going to be able to get that in real world. There's interference, whether it be from instrumentation in your lab, atmospheric interference, or just interference that's coming from other components of your system. So as you can see on the left side, we have the ideal perfect sinusoid. And then the right side, we have the real world signal, which has the random amplitude changes as well as random phase changes. And you can see the different peaks as well as the shifts in phase. So that's more realistic of what you're going to get in real life. So that's where the PNT comes in terms of measuring the phase noise and seeing how clean or how stable the frequency of your system is. And I believe Sam wanted to say something here.
Thanks, Edgar. Sorry about that. So at this point in the presentation, some of you are probably, wondering, don't spectrum analyzers, have the ability to measure phase noise, or just, why do I need the 7000 series in general? So we talked about this a bit previously, but the 7000 series provides a much lower phase noise measuring and testing capabilities compared to spectrum analyzers. And more specifically, spectrum analyzers will oftentimes measure the phase noise of itself rather than the device under test. So just a bit of a kind of background on that.
Yeah, so I mean, to kind of piggyback on that, if you're trying to test an extremely low phase noise system, if you're using a spectrum analyzer, even one that has the capability of doing phase noise testing, it that would the noise floor on that specific tester would have to be below what you're actually testing, or you're not getting the actual phase noise of what your DUT. You're getting phase noise from the internal system. So that's kind of you have them all in one with the spectrum analyzer, right? But yeah, you're not getting the low noise floor that you would get on a standalone PNT. So that's just one thing to kind of point out. In regards to our Model 7000 series, it's all-in-one compact unit. It fits on a benchtop or a desktop in the lab, or as we see later on in Stuart's setup, he actually has it combined in his workstation with all of his other test equipment. It is controlled through computer, whether that be through the GUI that comes with it or through serial communication. And it goes down to about 190 dBc per hertz. So it has a fairly low reading level, which, so for those extremely low phase noise systems, you're able to get those accurate measurements, down at negative 170 dBc per hertz and the like. And let's move on to the next slide.
Oh, and sorry to interrupt, just kind of backtrack a bit on the last slide. Let's go back here. Just to kind of add, so Stuart, he does have our 7300. And when he was looking for, phase noise systems, he was really kind of just looking all over the market. But as many can probably attest to, the units can be quite expensive. And we were really able to provide a customized solution, which, allowed Stuart to get into the phase noise measuring business. So, if you have any questions in regards to your application or need for the unit, feel free to reach out.
And another thing I neglected to mention, the Model 7000 does come in different variants, whether depending what frequency you need. So we have the 1 megahertz to 7 gigahertz, 26 gigahertz, or the 40 gigahertz. So we can kind of streamline it to your specific application and the frequencies you're working in. So one of the features of the 7000 series is the additive phase noise measurement, or residual noise. It's a nice feature that allows you to add components to a system, and you're able to determine how much phase noise it's adding to the system itself. I believe this is a newer feature. I think the unit that Stuart has actually doesn't have that feature, but I believe all the newer ones will have it. You can correct me if I'm wrong there, Sam. The phase noise and residual phase noise is important when you're designing either the synthesizers or VCOs. Or just a large system in general. You want to know which components are adding the phase noise to your system, so you can either replace it or figure out how to minimize that phase noise that's being added. And we're gonna show you some phase noise plots from some of the BNC synthesizers that were done here, either in the BNC lab, or we have them in the data sheets of our various units as well, so you can take a look at those. So I believe this is our 845M, and you can see the phase noise plot, and I believe the 845 goes up to 20 gigahertz, so that's where that's our max measurement here. But you can see the typical phase noise plot is going down as your offset frequency goes up. So, I mean, they're just, as you'll see, Stuart's phase noise measurements are very similar in shape. So, typical phase noise measurements. And this is our 865M. Also, this one goes up to 20 gigahertz. And you can see the different frequencies, carry frequencies, as well as the offset frequencies. And once again, typical phase noise plot. And as I said earlier, this is the setup that Valon Technology uses, and I really like this. It blew me away when I went to his lab and I saw it. I'm like, that is so, just everything's there and in one spot. And he actually has it rigged up so he has switches that are controlled through a computer program, so he's able to switch between his spectrum analyzer, power reader or the 7000 series, depending on what he wants to look at. And I believe he's doing, this is the 5009 was the one he tested for us while we were in his lab. But yeah, it was a really nice setup, and you can see how well the 7000 series fits into a testing bench. Like it's there, spectrum analyzer on top, power reading on the side. Very nice and compact. I really liked it.
Absolutely. And yeah, I'm not sure if I mentioned this before, but the 7300 is our 26 gigahertz model.
Okay. And here's some more shots from the lab, and this was Stuart. He was running some phase noise measurements for us, and you can see the plot there. And he did it on the fly, right in front of us. Very easy. The GUI is extremely easy to use. Even for someone who hasn't used it, it's pretty easy to get to understand how to use it and all the capabilities of it. And we'll see some of the capabilities of it in Stuart's plots, where we'll have like statistics and markers, things like that. And yeah, so now these are some of the plots he sent us. So one thing about the 7000 series, he was able to do the testing in his lab, and he sent us the data from his 7000 series, and we were able to open the data here in our lab on our software, and we were able to manipulate it, go through it, and look at different things. So that's the data sharing pretty much like between labs is pretty good there, because another lab might not have the phase tester, but they can they have the software and they want to open it up and check it. So that's one way to do it. Or you have multiple labs with phase noise testers and they're testing different components, and you're able to share that data back and forth, manipulate, and pinpoint problems. So that's one of the good things. And this is the 5009 series he tested for us there, or the model 5009, and he did 100 megahertz and 4 gigahertz. And these are the next plots I'll show you are those data points, and you can see typical phase noise plot, and you can see the different markers of the different phase noise levels as the offset frequency increases. And you can see similar with the 4 gigahertz, but kind of what I want to point out is this one, because you can see the statistics where you can see some like the RMS jitter, residual noise, things like that, as well as the markers actually being defined on the plot itself, as well as the frequency and power readings. So everything's just right there on your screen, very intuitive, easy to read. And this was for the 100, and you can see here for the 4 gigahertz as well. So yeah, just very intuitive and easy to read. There's a lot of applications that the PNT fits into. Digital communications being on the forefront. As I had a conversation with Stuart yesterday, and the phase noise is extremely important in terms of digital communication, because depending on your modulation scheme, if you have too much noise, you might not even get any actual data out, like when you're reading it, because it's been just covered. You can't take the data from the phase noise. So being able to determine the phase noise of your system when you're designing digital communications, or you're testing VCOs, time stability of clocks in aerospace and defense, you're testing antennas and radar, things like that, and they all need extremely low phase noise and very stable frequencies. And with the PNT, you're able to determine if any issues you're having are coming from phase noise, or if the phase noise is well within specifications of your system. So I mean, these are just some of the applications. If phase noise is something that you have that is one of your specifications that need to be kept low, contact us, and we'll discuss your application with you and see if the PNT is a good fit for your application. So I mean, we're always here to help all of our customers, and that's what we do. We try to get you the best equipment for your application.
All right. Well, thank you for that, Edgar. So here's just a brief overview of our BNC Academy. Edgar has actually contributed to the RF boot camp and the quantum computing course with a couple of videos. So shout out to him on that. And yeah, so our Academy is a very dynamic and engaging resource for those looking to get kind of ahead of the curve in regards to the types of instrumentation you'll be using pre or post college. It's also a great resource for those looking to kind of freshen up their knowledge, perhaps gain some new insight as well. So if you're an employer or a professor as well and would like to make the Academy a resource, please feel free to reach out and we can get you in touch with our Academy administrator to make that happen.
Just kind of piggyback on that. I mean, I did some of the work on, I think, the RF bootcamp as well as the quantum computing. I mean, I knew I knew those subjects fairly well, having studied them in college, and even then, it was still, you know, very fun to go through them and just kind of refresh on a lot of the stuff. And so, anybody who's like-minded, future engineers, physics majors, they would more than likely love these academy courses because the information in them is just invaluable. And if you're technically minded, it's just fun to read that stuff. So.
All right, so now we can segue into our question and answers portion. It looks like we've had a fair amount of questions from the audience. Our senior RF applications engineer, John Latter, has been going through those there. Yeah, thank you so much for your questions. We'll just kind of wait for these to kind of funnel in a little bit. And actually, I see here that Stuart Rumley of Valon, he is in our audience. So Stuart, if you're out there and would like to add anything at this time, feel free to join.
Good morning.
Good morning.
Well, I don't have anything to add other than I did see the comment about the need for sources, and the kind of the magic of the BNC 7000 series analyzers is they have the sources are built in, and the methodology, the extended phase noise measurement capabilities, kind of, to me, has always seemed like a magic trick in math that you split the signal, take two uncorrelated sources, the net result is the three things with the two uncorrelated sources, and the third is the correlated noise from the device under depth. So I think John Lauder answered that question pretty well. So good morning, guys.
Yeah, well, thanks for that, Stuart. Definitely some great insight. In regards to any additional questions that someone would have just in regards to the 7000 series, and just to kind of differentiate it a bit from the synthesizers we've discussed today, there are a very large suite of options for both the 7000 series and then our synthesizers. Obviously the options that will be featured on the 7000 series will much more be tailored to just analyzing phase noise. Some of the options you'll see will be AM noise analysis, burst mode, phase measurements, along with additive phase noise measurements as well, which is our APN option, TRAN, which is transient measurement, and then T-stab, which is our time stability analysis. And then, with our synthesizers, obviously, there is a focus on the effects of phase noise, but there'll be more options just in regards to switching speeds. So that's our FS option, harmonic filtering, which is the FILT option, and then frequency and phase modulation with our FM option. So as myself and Edgar have touched on, feel free to reach out. We're really trying to ensure that you're getting the most cost-effective configuration possible. If you think you need an option, perhaps maybe you don't. So we can definitely do all this as efficiently as possible. Let's see if there's any more questions. And then a question we definitely do get often is how our unit sizes up to the competition, obviously. So on our website, we have a couple of comparison charts with a Keysight unit of similar caliber, and then also Holsworth as well. Something we're more than happy to do. If you have a particular unit in mind that you're also evaluating, we can certainly put together a formal comparison, just a chart basically showing the performance specs of each unit, just so you're able to kind of have that on one page. We definitely know it can be a lot just having to demo these units, and they kind of just compile all the information. So we're more than happy to do that. Another thing, just lastly, that I'd like to add, where we often get questions about, is if a service agreement will be needed. So we do have our service agreement, which includes annual calibration with NIST traceable certification, all repairs, service requirements, shipping and handling charges, they're all taken care of if you get the service agreement. It also includes system upgrades, firmware and software enhancements, and then of course unlimited application and then technical support. It also comes with a class pass to our Berkeley Nucleonics Academy as well. And then the pricing for the 3-year service agreement is typically 18% of the total price of the unit. And then you do get 3 calibrations. So you could have maybe 3 yearly calibrations, or maybe you stretch 3 over the course of 5 years or something like that, whatever comes first. So it's definitely a great option. It's definitely a great option for a lot of our customers.
Also, I think, we had a question. What was it? Do we have plans to do a public white paper about additive phase noise measurement?
Yeah, that's a great question. We could very well have a document like that. We just haven't posted it on the website yet, or maybe we have. We'll definitely get an answer to that, though.
I think we're always releasing as we get them white papers or just informational documents on a lot of our products. Let's see. Are these available for loan? Did you answer that one already?
Oh yeah, so that's a great question. So as I kind of mentioned a little bit in the presentation, we do have demo units. We definitely like to ensure every kind of last little bit of your application and any sort of roadblocks you might run into with a potential demo. So once all that's kind of ironed out, we'll send you a demo. We'll send you the demo agreement form. You can fill it out with the unit you will be demoing, and then we'll send the unit to you for a 2-week loan period. If you need to make any additional measurements or there's time constraints, we can certainly extend that, and there is some flexibility there. But yeah, we definitely really enjoy sending out demos to our customers. We definitely understand it's not a cheap unit, so we definitely want to ensure that proof of concept is there before any purchase does take place. All right, so let's see. We have a question from Mr. Gonzalez. Any future trade shows? So we're doing trade shows a fair amount. I would say for all of our product lines, we're getting to maybe about 1 trade show a month. We will be at IMS in Denver, so please feel free to keep that in mind. That is around mid to late June. So definitely, I would love to see you there. I believe the 7000 series will be there as well. And we'll have it, hooked up to the laptop, and the GUI will be running. So you'll be able to stop by and check that out firsthand. Okay, is there an external battery pack option? Yes, I believe so. So, this is a field-ready unit. So if you do anticipate being out in the field for quite some time, there definitely is that option. So you don't have to rely on a wall source or anything like that. Well, yeah, thank you, everyone. Definitely a lot of great questions. We'll get to any additional ones offline. So on behalf of myself at BNC and Stuart at Valon, we greatly appreciate you taking the time to join us today. If you anticipate a need for the 7000 series or synthesizers, please feel free to reach out. So here's our direct contact information. So please feel free to reach out to us there. And thank you everyone so much for your time today. We really appreciate it. And have a great rest of your week.